Thank you for listening. I'm Tomomi Samejima from Tokyo Gakkai University International Secondary School. My research is the significance of inquiry-based learning of IB program from the perspective of active learning. I work at an international baccalaureate school in Japan and I am researching the IB education in Japan. With the support of Ministry of Education, Culture, Sports, Science and Technology, next, the number of IB schools in Japan is increasing, and this is having an impact on science education in Japan. In this presentation, I will discuss IB science courses and Japan science courses from the perspective of active learning. Purpose of the study. In Japan, with the revision of the course of study, school education is required to develop the qualities and abilities necessary to become the creators of the future even in the midst of rapid social changes such as information technology and globalization. Active learning has been listed as one of the specifics of this direction. However, there is no specific method to realize it, and it's not an end in itself. The purpose of research is to propose the improvement of courses from the viewpoint of active learning by quantitative analysis of unit design and the process of inquiry-based learning based on IB methods using RTOP. The Reform Teaching Observation Protocol (RTOP) was developed as an observation instrument to provide a standardized means for detecting the degree to which K-20 classroom instruction in mathematics or science is reformed. There are five categories of RTOP shown here. We evaluated science courses on these items. Each item is further subdivided into five detailed items, each scoring 4 points for a total of 100 points. In order to understand the indicators of our top, three lessons were designed and implemented with the same learning content. The learning term is concentration. The first was a passive lecture style class. The second was a teacher-led inquiry-based class, and the third was a student-led inquiry-based class. The third type of class was designed based on the International Baccalaureate method of instruction. In many Japanese schools, either number one or number two type of class is implemented. The purpose of number one lesson is to understand moral and percent concentrations. The purpose of number two lesson is prepare solutions with the accurate moral and percent concentrations. Number three lesson is to learn about concentration in chemistry based on a discussion of how the concept of concentrations is used in the real world. I explained the first one, lecture-based passive classes. In the introduction of the class, the teacher explains the theme of the class. The teacher then gives the students an assignment to calculate the concentration. The students do the calculation based on the teacher's explanation and check their answers. Finally, the teacher gives a lecture on how to prepare solutions. The students in this class were quietly participating in the class, but did not speak up. It's not really active learning. However, this kind of class is often taught in Japan. I explained the second one, teacher-led inquiry-based lessons. In this lesson, the teacher prepares the inquiry questions. The first question is, how do we prepare solutions of moral and percent concentration? Students discuss in groups using the whiteboard. Once that is resolved, the teacher gives them the second question. The second question asks about the lab equipment needed to prepare the solution. Students do not follow the instructions. It is important to choose the correct equipment in order to perform the experiment with clear perspective. Finally, the student to actually perform the solution preparation. The students in this class say that they are able to deepen their understanding by actually experiencing the operations. The third class is a student-led inquiry-based class. This lesson utilizes the International Baccalaureate Unit Design method. It is a chemistry class, but it is introduced from a real-world situation. The first question is, how is concentration used in real-world situations? The students give various examples. The next question is about the impact of showing concentration quantitatively. A discussion begins among the students about the impact of quantitative values in real-world situations. This is where the student initiative begins. Discussions about concentration began to develop without any instruction from the teacher. Finally, to expand the discussion to the chemistry area, the teacher asked about the difference between 0.3 mole per liter and 0.3% and discussed the specific situations in which each would be needed. The students were able to connect what they learned in chemistry to real-world situations and deepen their discussion. Evaluation by output indicators showed that class number 3 had the highest score and class number 1 had the lowest score. I did a survey after the classes. The result is shown here. The student who took the passive class asked the teacher for the correct answer. The student who took the teacher-led classes said they learned the most chemistry. In the student-led class, many students said it was difficult to understand, but they enjoyed the class. They also looked to the teacher for advice, not for the right answers. Most of all, they find the joy of learning. Even though the lessons cover the same learning content, the design of the units differed in this way. In this study, the unit design of IB was evaluated using the RTOP indicator. As shown here, IB and RTOP have the common concept of student-centeredness. Therefore, I think it is possible to get a high score in the RTOP indicator. In order to develop student-centered lessons, it is necessary to develop from existing knowledge using contexts and concepts, rather than teaching new scientific content. Conclusion. From lessons today, lesson design based on the IB methodology is used to achieve a high score on the RTOP. However, full marks cannot be reached because RTOP has perspectives that are not taken into account in IB. Also, both are learner-centered. Learner in IB is within the scope to teacher, while the learner in RTOP is beyond that. To improve classes, conceptual learning in the IB requires teacher or student-led inquiry-based learning. This creates opportunities for learners to learn from each other and for deeper learning that connect what is learned to the real world. It is necessary to change the mindset of teachers that conceptual understanding and collaboration among learners will lead to deeper understanding, rather than teaching the content of science learning. Thank you very much for your attention.